All of you switch on the camera. कितने लोग आए अभी तक? अभी तक 11 लोग. Prashad and Binit, switch on the camera. I had given you a problem yesterday. I want to know if you have done it or not. अभी तक 11 लोग, अभी भी 3-4 लोग बाकी है. मोरिया किधर है? मोरिया? He is not there. So if you haven't done the problem that I had given yesterday, start it. That camp follower mechanism, I had asked you to find out the Fourier coefficients A0, A1. Those who have joined, switch on the camera. Moria is joined now. Richa, is it that cold in Nagpur?
Yes, sir.
It's very, very cold. Okay. Good. You had another class now.
Yes, sir.
Rabba, how is Hyderabad?
Sir, it is also very cold here.
But if you look at Nandana, you are not in Hyderabad. You are in Hannamkonda.
Visakhapatnam, sir, but it's
Oh,
very cold.
Visakhapatnam, is the ideal weather now. It is in the sea beach. Okay, good. But Nagpur is really very cold. Very, very cold. Okay, so how many people? 14 people. Sahil, are you there? Sahil, kidhar gaya?
Yes, sir.
Good. So we can start. All of you, I had asked you a particular problem yesterday. That was periodic excitation by a camp follower mechanism. So let us see how we can handle it. So you can take out your camera and let us go to the PPT. Yes, this was a problem. But as an engineer, how do you look at the problem? Let's have some discussion. You forget how to solve it. Okay, I'll come to that. How to solve this question, I'll come to that. But do you see something far-reaching, far more important? So, suppose you can solve this problem. How to solve? We will discuss in another 15 minutes. But without arriving at the solution, can you tell me, this gives us a very interesting conclusion. What does it mean? UG student, particularly UG student, I had given you an example yesterday that in IC engine, valves are operated by camshafts. Okay. So this may be seen as a camshaft rotating, opening and closing the valve. So this may be the valve body. Fine. You have learnt in second year how a specific motion can be obtained from cam follower mechanism. That you have studied in second year. How a specific motion can be obtained using cam follower mechanism. Fine. Accordingly, we design the cam profile. So here the cam profile is designed such a way that follower is supposed to follow sawtooth curve. Fine. But after you finish this problem, what do you learn? An interesting thing you learn. What is that? ये सब चुपचाप बैठे हुए हैं. That means second year you have learnt nothing because it was taught online. Second year was taught online, you learnt nothing. No, you should not remain silent. After you solve this problem, what interesting thing you will learn? Not values, concept-wise. As an engineer, that is a very important finding. What is that important finding as an engineer? सब चुपचाप है. हम भी बैठे रहेंगे चुपचाप 1 घंटा. So you are unable to say anything. ठीक है? Then I am stopping the discussion. Discussion करके there is no point having discussion when you are not interested. So let us solve the problem. ठीक है? Let us solve the problem. So what are the Fourier coefficients? And how do you solve? How do you solve this differential equation? This is the differential equation where right hand side is a Fourier series. So what are the Fourier coefficients and how do you solve it? If you have not done it before, you do it now. What are the Fourier coefficients? A0, A1, B1, A2, B2. I have given the formula yesterday.
Yes, sir. A not equal to 25 mm. A not 25 by 2.
Acha, I haven't solved it. Okay, I thought I have solved it. Fine. I haven't solved it. Anyway.
Sir,
हाँ बोलो.
sir, A naught is 87.5.
No, your A naught is what? Again, your K1 bahar hai. Don't multiply K1. Then you say how much is A naught. Okay, you mean to say including the force if you are doing it. No, I'm saying go by this expression and then tell me how much is A naught and other things.
Okay, sir.
Not 25 mm. A1 is 0. A and B1 will be minus 25 by pi.
What about B2, A2?
A2, AN will be 0 irrespective of n, and BN will be minus 25 upon n pi. N will be number which.
Okay, ठीक है. That is correct. That is correct. So now you tell me, okay, fine. So we know how to find out A0, A1, B1, A2, B2. Now, for AG, this is a static force. So this is a static force. The static deflection will be force divided by stiffness. Stiffness is K plus K1. So force is K1 into A0 by 2. This is a static force. It will introduce a static deflection. Static deflection is static force divided by stiffness. Static force is K1 into A0 by 2. This is static force. Next, we have a harmonic force K1 A1 into cos omega t. A1 0 hai, so we will not consider it. Next is harmonic force K1 B1 sin omega t. This is not 0. So K1 B1 sin omega t, its response we can find out by our harmonic excitation formula. It will be K1 into B1 divided by stiffness, K plus K1, and then dynamic amplification factor. So the response X1, because of X1s is the response coming from sin omega t, X1c is the response coming from cos omega t. X1c 0 होगा क्योंकि cos omega t का कोएफिशिएंट 0 आ रहा, but X1s will not be 0. P1 comes out to be non-zero. So what will be X1s? X1s will be K1 into B1 is the magnitude of the force divided by stiffness K plus K1 into dynamic amplification factor into sin omega t minus phi 1. Fine. Remember, dynamic amplification factor R is omega by omega n, but omega n is square root K plus K1 divided by m. Omega n is square root K plus K1 divided by m. Remember that. Now, this is for A1 cos omega t, B1 sin omega t, A2, B2, A3, B3. How many terms we should find out? So this is how things come up. This is how finally things come up. So we have to calculate not only for the first Fourier coefficients A1, B1, we have to calculate for A2, B2, A3, B3, A4, B4, A5, B5, because Fourier series is an infinite series. Question is, how many terms we calculate? So now there is a problem in periodic excitation. In periodic excitation, we are taking help from Fourier series. And Fourier series is an infinite series. So we have to calculate response for each term, and there are infinite number of terms. So how many response we should calculate? That is a big question. Can anybody answer it? Should we stop up?
Can we, as it is forming a GP series, we can sum up. We have a, and also
No. We cannot sum up. We cannot sum up. GP series is only the magnitude of the force, but sin omega t minus sin n omega t minus phi n, उसको क्या करोगे? In exam, how many terms you will? Suppose this is a 24 hours exam. You cannot complain about time. This is a 24 hours exam. You cannot complain about time. How many terms you will calculate? I mean, this is a practical problem with periodic excitation. We are taking help from Fourier series, and Fourier series is an infinite series. For each term, we can calculate response and add them up. But how many terms? Only first 2 terms? Only first 3 terms? Or only first 10 terms? Who will answer it? There is an answer. There is an answer. It is not absurd question. It is a very intelligent question.
Sir, I think at least 4.
At least 4. किसने बोला?
Sir, Vineet.
But I have given you 24 hours.
Sir, because like the frequency of each of those like small
No, but
excitations
I
is
have given you 24 hours. Will
So
you still
exactly,
limit
that's all.
yourself to 4 terms, or you will try to go up to 6, 7 terms?
I mean, could go up, but at some point the frequency will be so high that it won't be, of very much significance because the excitation will be very small
So how do
and the
you
frequency will
decide? How do you decide? How do you decide that it will not be, when it will not be significant?
Sir, I think depending on our units, like the mass is given in kg or meter. If it is smaller, gram and mm, then up to 2 to 3.
No. That is not the answer. No. This is an intelligent question. And there is a specific answer. Clear-cut answer. Nothing vague. I think somebody just now answered, he was partially correct. We will stop when response becomes small, response becomes insignificant. But how do you know when it will become insignificant? Answer is in the PPT. Answer is in the PPT. आप थोड़ा दिमाग लगाओ. That is why I said, that is why there was a time when my students used to bring Mentos in the class. Have you seen the advertisement of Mentos? रिचा कभी देखी हो? दद्दू दिमाग की बत्ती जला दे.
Yes, sir.
याद आ रहा कुछ?
So,
There was a famous advertisement by Mentos. दिमाग की बत्ती जला दे. My student used to bring Mentos in the class. तुम लोग को भी Mentos रखना पड़ेगा अभी लग रहा. ऐसा लग रहा.
So for this particular question, since we know that these small excitations or sub-excitations, in those the amplitude is like dependent on AN and BN. So now, since in this particular question we know the value of BN for any n, we can as per our needs we can decide as to at what value of n the value of amplitude of that excitation will be far too low to consider.
Okay, suppose I give you a data that we neglect excitation if its contribution is less than 10%. चलो क्या करोगे बताओ. Now 1 by n, everybody knows that 1 by n decreases as n increases. ठीक है. So if I say 10%, do you mean to say then you have to go up to 10 terms?
Yes, sir. I suppose.
So you have to go 10 terms. Agree?
Yes, sir.
But and now suppose this problem is given in 1 hour exam. What you will do? Can you go up to 10 terms?
No.
Anyway, so that is not the answer. 1 by n is not the answer, because in another problem that the coefficient may not be 1 by n. In another question, the coefficient may be something different. So that is not the answer. Answer is there in this PPT itself.
Sir, sir, the DF formula we have in the denominator n square by r square. Sir,
that is the correct answer. Okay, you are correct. That is the correct answer. We will continue as long as DAF is significant. We know DAF is significant up to √2. Beyond √2 क्या होता है? DAF 1 का नीचे चला जाता है. Agree? So suppose we take a decision that we will go up to root 2, frequency ratio to root 2, because roughly up to root 2, DAF is greater than 1. That you agree or not? Whatever may be the damping, DAF is greater than 1 up to root 2. Beyond root 2, DAF is less than 1. So say, let us take a decision. We will go frequency ratio up to root 2. So what does it mean? N into R is equal to root 2. N into R is equal to root 2 will decide what is the value of N. Say in this case, have I given you, बताओ, in this case, हमारा R का वैल्यू कितना आ रहा, कैलकुलेट करो, ओमेगा n कैलकुलेट करो, एवरीथिंग इज गिवन हियर, एवरीथिंग इज गिवन, मास दिया हुआ है, K दिया हुआ है, K1 दिया हुआ है, कैलकुलेट ओमेगा n, ओमेगा भी दिया हुआ है, ओमेगा कितना है, 60 RPM. So what is R1? What is R2? I mean, what is NR? R2R, R निकालो पहले, R कितना आ रहा? Let us find out R is how much.
$10.63.
हाँ?
10.63.
R का वैल्यू 9.63 आ रहा.
10.63.
So 0.33.
Different people are telling me different thing.
Even I got 10 actually in the starting. It's actually kilonewton. The value of K is in kilonewton.
R कितना आ रहा, ठीक से बताओ.
0.33.
0.33. Should I go for second term? Second term में it will be 2 into R. DAF, in the DAF formula, in the denominator you will put 0.66. So this is the, you have to be careful. First term 1 minus 0.33 square. Second term 1 minus 0.66 square. Third term 1 minus 0.99 square. And now you look at third term will create a resonance. Or in other words, contribution coming from third term will be much more, even if amplitude of the force has gone down 1 by 3, because it is 1 by n. Third term, amplitude of the force has gone down 1 by 3, but DAF has gone up. So this is the most dominating term in the response. Even if it is, I give you 10 minutes, you have to at least calculate third term. You have to go to fourth term. You have to go to fifth term. So how many terms you have to include? It depends on the value of R, such that N into R goes up to root 2. You can take a further decision. Why root 2? I can take all the terms, still dynamic amplification factor is 0.5 or 0.1. Then you can have another value of R. Right now, generally we take up to root 2, because below root 2, dynamic amplification factor is greater than 1. Above root 2, roughly, dynamic amplification factor is less than 1. So we see that in Fourier series, we have a tendency to calculate first term, second term, and then neglect higher terms. It is a mistake. the term that is coming close to 1 has to be included. If it happens to be 15 term, I have to go up to 15 terms. I cannot stop my calculation in second term and third term. So it depends the value of n such that n into r is close to 1 and n into r goes up to root 2. That is how number of terms are decided. So once we know how many terms we have to consider, we find out the response, add them up. So that is how we solve periodic excitation problem. It is not easy, it takes time. First of all, we have to apply Fourier series and we have to find out the coefficients A0, A1, A2, A3, etc. That is one trouble. Second trouble, we have to calculate the response for each term and then add them up. So how many terms we should consider? It depends on n into r value. Generally, we take n into r up to root 2. Okay? So this problem I cannot ask in the exam because a single problem will take up at least 1 hour. But this is how we handle periodic excitation problem. कुछ पूछना है किसी को? Any question you have?
Regarding interesting thing you are talking about in starting.
So now you answer. Yes, you answer. My job is to raise the question. Your job is to answer. Salary को किसको मिलेगा नौकरी में? मुझे तो नहीं मिलेगा salary. What is the interesting thing? It's important, not only interesting, it is highly important. And that is why a student should learn vibration. Because our approach in engineering completely changes when we look at the problem through the subject of vibration. किसका घर में मेंटोस है? So from next class you should have मेंटोस. पीपीटी में कैमरा में दिखना चाहिए कि सबके पास मेंटोस है. हाँ बोलो. This problem is now that you are able to find out the solution, as an engineer, an interesting thing you learned, what is that? And if you say we don't learn anything, bluntly I will say don't expect any job from a company.
Velocity will be different in upward and downward motion. Velocity will be different in upward and downward motion.
Answer is easy. Answer is very easy. See, this is a problem with present generation students. They can't think beyond their mobile. Thinking capacity has gone down, deteriorated like anything. Present generation students simply cannot think. They have become robot. जितना सिखाएंगे उतना ही बताएगा, उससे आगे कुछ सोच ही नहीं सकते हैं कोई. This is very important discussion. This gives us a very important information, which is not good. The important information that we learn is, it tells us that there is a challenge, there is a problem. It doesn't tell us that things are better. It rather tells us that things are bad. Why things are bad?
Sir, maybe because the motion is not transferred properly.
Correct. That is the answer. That is the answer. We design the cam follower such that the follower should move exactly along this picture. And we believe that along with the follower, my final valve should also open exactly as per this line. But what do we learn once we solve it? That the valve does not follow this graph. Valve follows another formula. The valve movement is given by X. X will not look like this. X will be maybe close to this, but definitely not same as this. So I have designed a cam and I presume the ultimate motion that goes to the valve also behaves the way follower behaves. That is our assumption. In real life, valve has its own motion. How much different? One needs to study. One can do the argument that X will be almost same as X1. But if you solve this problem, and if you solve this problem up to 5 terms, 6 terms, and if you plot X, you will see X is different from X1. So, this tells us that we design something and something different happens. An engineer cannot run away. He has to solve it. This is very important thing. So whatever you have learnt in second year, that is incomplete. In second year, you have designed a cam. And then you said that if the cam profile is a sawtooth curve, my purpose is served. The valve will open and close exactly along this sawtooth curve. But in third year, when you study vibration, you realize that reality is different. Reality is far more challenging. And because reality is far more challenging and engineers are given high salary only if he learns vibration, only if he can handle this problem. If you cannot handle this problem, you will be given a salary of 3 lakh rupees per year. Nothing more than that. Nobody will give you more than 3 lakh rupees per year. The kind of engineers you are becoming nowadays. Why people should pay? So this is the interesting thing, that I have designed a cam and I am under the assumption that the ultimate motion that goes to the valve will exactly remain sawtooth. It will not, because of the vibration. So what I have to do? I have to not only analyze, I have to plot X, and I have to see how much different X is. Now, can anybody tell me what is your prediction? X1 के आसपास होगा कि भयंकर अलग होगा? You can answer it in this problem.
So it should be different, I think, because the different components of little excitations will have different phase differences.
No, not that. There is a specific answer. In this problem, X will be drastically different from X1. Why?
So because each component has a different phase difference.
That is another thing. X is not each component. X is summation of all the components. Agree? Each component will be different from each other. No doubt about it. But the summation will be drastically different from x1. Why? In this problem. Because there is a near resonance happening. N is equal to 3. Almost resonance is happening. So resonance will unnecessarily amplify x. Try to understand. Resonance will unnecessarily amplify x. What we should do? Suppose as an engineer you have to take a corrective step. What corrective step you will do? Let me see. Let me see. अभी धीरे धीरे एमटेक के स्टूडेंट बीटेक के स्टूडेंट दे विल स्टॉप कंप्लेनिंग जॉब नहीं मिल रहा they will stop complaining. If they go through the subject called vibration, they will never complain कि नौकरी नहीं मिल रहा. हाँ बताओ, अभी बताओ. Now we have understood that x is going to be significantly different from x1. तो एक कैंप फॉलोअर मैकेनिज्म तो चलेगा नहीं. एक कैंप फॉलोअर मैकेनिज्म चलेगा नहीं. हल्ब अपना हिसाब से उठपटांग खुलेगा बंद होगा. सॉटूथ कर्व का हिसाब से भाल्व खुलेगा नहीं बंद नहीं होगा. सो व्हाट इज द मेडिसिन यू विल सजेस्ट? In this problem, I am saying in this problem we find that third term goes very close to the resonance and it becomes so large that summation also goes up. If the third term gets amplified 10 times, my total summation also will see a spike. तो अभी क्या कर सकते हम? What you think is the best thing you should do?
Decrease R.
नहीं.
Sir, increase damping.
सैलरी 10,000 बढ़ेगा, 2 लाख नहीं बढ़ेगा. ऑल द गर्ल्स आर साइलेंट. क्यों? घर में खाना पका रही क्या ये लोग?
So we can try to increase the value of R such that like the first value of R itself is greater than 1. Okay, that is a good idea. Let us go for omega by omega n greater than root 2. See, why I am root 2? Why I am so much obsessive about root 2? क्योंकि फिर डैम्पिंग का चिंता नहीं करना पड़ेगा. Agree? See, damping becomes a deciding factor around resonance. root 2 के बाद डैम्पिंग के लिए ज्यादा फर्क नहीं पड़ता. You see your DF graph? Damping hardly plays any role beyond root. So, if we can keep omega by omega n greater than root 2, my dynamic amplification factor will be less, irrespective of n. So how do I make R greater than root 2? क्या करना पड़ेगा? मुझे as an engineer, what specific decision I have to take? In this case, the R is omega by omega n is coming out to be 0.33. So what is that specific decision I will take? change the value of natural frequency and accordingly change the value of stiffness.
So say the final answer. I will increase the value of spring, stiffness of the spring. Now, should I increase K1 or should I increase K? Or should I increase both? Or should I decrease them? Should I decrease or should I increase? Should I increase omega n or should I decrease omega n?
We should decrease omega n.
No. Omega n we should decrease or omega n we should increase?
Decrease.
Decrease.
Omega n we should decrease. So should we decrease K1 or should we decrease K or we should decrease both?
So I think one of K and K1 was in the numerators for the amplitude. So like decrease the one which was in the amplitude.
So
So
which one? K or K1?
I don't remember the formula actually.
See, if we decrease K1, not only the natural frequency decreases, even the force decreases.
Yes,
Fine.
it will open less.
No. But however, this force should be sufficient so that the valve opens. अगर K1 इतना कम हो गया that the force that goes to the valve is unable to open, तो नहीं चलेगा. Okay, so in general, we will reduce K and K1 both in general or one of them. That is the correct answer. We will reduce either both or one of them so that omega by omega n crosses over root. So this is a very practical problem and no textbook discusses it. Even the textbook in which it is given, they are only discussing vibration. They are not discussing how an engineer needs to take his decision accordingly. So this is an example which highlights that our conventional design is inadequate. So that the design that an engineer has done based on his theory of machine knowledge is inadequate because the follower motion is perfect sawtooth, but the valve motion is not perfect sawtooth. It will deviate and it's a big problem. We can handle the problem by adjusting omega n or omega by omega n ratio. So this question I wanted to, that is what I said, that there is an interesting thing, there is an important thing. Okay? So I don't want to begin my next discussion today. Aaj itna hi, I am going slow. Tomorrow 9 o'clock you have the exam, don't forget it, just 40 minutes exam. We will start exactly at 9 o'clock, so you should log in 5 minutes before. Class test. Tomorrow morning 9 o'clock se chalu hoga. Okay? And then Tuesday we will go into 2 degree of freedom system, Lagrange equation, and after that we'll again come back to single degree of freedom system but transient excitation. This was periodic excitation. Transient excitation will take 4-5 lectures and that will be, I think, syllabus before first midterm. Okay? So आज हो गया. I am not sending any PPT because we have not discussed anything new today. बराबर है. ये प्रॉब्लम को सॉल्व करो. कितना टर्म लेना है? R is equal to 0.3, तो कम से कम 5 टर्म लेना है. ठीक है? 5 टर्म लेके x को प्लॉट करो. Plot x. Take summation of all the 5 terms response, then summation, whatever that summation comes, you plot it versus time t. In a computer MATLAB, you can do it. In a MATLAB, you can do complete calculation also. You can write a program and MATLAB will do all the calculation. MATLAB will sum up x1, x2, x3, x4, x5. MATLAB summation करके final x MATLAB plot करेगा. So, and then you will realize that actual valve motion is not desired sawtooth motion. It is something else. It is something else. And who is the culprit? Culprit is that third component who is going close to the natural frequency. ठीक है? तो this is your home task. करके रखो. Then only you will really get a feeling of engineering. Engineering is much more difficult, not as simple as you learn in engineering colleges. In engineering colleges, last 20 years, we are not teaching anything. We are simply not teaching anything that is engineering in engineering colleges. We are teaching very, very ordinary things, and students are thinking they have become engineer. That is the problem. Anyway, चलो आज का क्लास हो गया. कल क्लास टेस्ट है 9
I have
बजे
a
से.
doubt in a question assignment.
बोलो बोलो बोलो. न कौन सा
In
क्वेश्चन? न कौन सा क्वेश्चन?
Sixth one.
असाइनमेंट प्रॉब्लम.
Yes, sir.
तो कल का क्लास टेस्ट हो जाने दो. आई डोंट नो कौन सा प्रॉब्लम क्लास टेस्ट में डाला है. ट्यूसडे बात करेंगे. ठीक है?
Yes, sir.
नहीं, अभी क्लास टेस्ट है ना, इसीलिए आई एम पेंडिंग द डिस्कशन. अब मुझे मालूम नहीं क्लास टेस्ट में अगर वही प्रॉब्लम होगा तो उसको तो आज डिस्कस नहीं कर सकते. तो ट्यूसडे करेंगे. चलो हो गया. यू कैन लीव.